All right, so the next thing we're going to look at with our polar coordinates is how to take an equation that's in polar coordinates and convert it back into rectangular coordinates with our x's and y's. Now, in order to do this, we're basically going to use the same formulas we did to convert points. So we can use the fact that x equals r cosine of theta, y equals r sine of theta, but also these two formulas right here, x squared plus y squared equals r squared, and tangent of theta equals y over x. So let me go ahead and just jot those down so we have them convenient. And we can use any of these in order to make these conversions. Okay, all right, so if we're looking at example 5a, we're starting off with the equation r is equal to 5 times the secant of theta. Now, none of our formulas over here have a secant in it, so the first thing that I would do is just change that secant to a 1 over cosine. Let's make it a 5 times 1 over cosine, okay? Now, by doing this, we've created a fraction. So in order to simplify this, I'm going to go ahead and just multiply by cosine on both sides of this equation. Okay. Now, of course, that just means that the cosines are going to cancel on the right-hand side, and we would have r cosine of theta is equal to 5. Okay. Well, now, if we take a look at our formulas right here, we know that x is equal to r cosine of theta. So this equation just becomes x is equal to 5. So we've gotten rid of all of our polar coordinates. There's no r's and thetas left. We only have rectangular coordinates. Okay. Now, if you're looking at this saying, wait a second, but what about y? Okay, remember this is an equation. So you're thinking about the equation x equals 5. This is just saying that this equation is the vertical line at x equals 5. So this is the entire equation. It doesn't have to necessarily have both an x and a y in it. As long as it has only x's and or y's and no r's and thetas, then it is in rectangular form. Okay, and just to point out here, sometimes your textbook, they're going to refer to that rectangular form as standard form. Okay, so if you see standard form, that's the same as saying rectangular form. All right, let's take a look at another one. So this time for part B, we have r is equal to 2 sine of theta. So again, we currently are in polar form because we have r's and thetas, and we're trying to convert this into rectangular form with x's and y's. And we're trying again to use these formulas up here as a way to convert these. So sort of think about these guys as like your identities, okay? So we're trying to use those in order to transform this equation. All right, well, looking at this, I can see that we have the sine of theta over here on the right-hand side. Now, using our identities up here, we have a formula that says y is equal to r times the sine of theta. Well, we don't have an r in this equation like we need, but that's a pretty easy fix. So what I'm going to do is I'm going to go ahead and I'm going to multiply both sides of this equation through by an r. All right, so if we do that, this becomes r squared is equal to 2r sine of theta. Okay, now we have some things that we can substitute. So if we think about this, r squared, according to our identities over here, r squared is equal to x squared plus y squared. I can make a substitution right there. All right, and then r sine of theta is equal to y. Okay, so we've gotten rid of our r's and thetas, we've replaced them with x's and y's, so that is going to be our answer. Okay, now this type of equation, we haven't actually looked at this yet. Our whole fifth unit is going to be focused on equations like this. This is something called a conic equation. So our whole fifth unit is going to be focused on graphing things like circles, ellipses, parabolas and hyperbolas, and we're going to come back around to things like this. For now, you don't really have to know how to graph it or what it is even, just take your polar, change it to rectangular, and you're done. Okay, don't worry about trying to really do anything in terms of simplifying this. Just once you get it as x's and y's, you're pretty much good to go. All right, let's take a look at one more of these. This time we have r is equal to 2 plus 2 cosine of theta. So just like the last one, I'm looking at this and seeing that we have a cosine of theta. But if we think about our identities up here, I really want an r cosine of theta. So I'm going to do just like I did last time, and I'm going to multiply by r on both sides of this equation. So we have r squared is equal to 2r plus 2r cosine of theta. All right, so then I'm going to make some substitutions. So I know that r squared, just like we set up here, is equal to x squared plus y squared. Now we don't have anything just for an r, right? If we look up here, we don't have anything that's just for an r. So I'm going to leave that alone for a minute. I'm just going to leave that as a 2r. And then the r cosine of theta is equal to x. So this would become plus 2x. Okay, so I got rid of most of the r's and thetas in here, but we still have to deal with this r right here. So because we still need to get rid of this r, I'm going to try and isolate it. So I'm going to go ahead and subtract 2x from both sides of this equation and get that 2r by itself. Okay, all right, now if we think about our identities, we have several possibilities for things that have r's in them. We know that x is equal to r cosine of theta. We know that y is equal to r sine of theta, but we don't have a sine or a cosine over here, so those aren't really helpful. And we also know that r squared is equal to x squared plus y squared. Now we don't have an r squared, but we can pretty easily get an r squared just by squaring both sides of this equation. So if we do that, we'll have x squared plus y squared minus 2x, quantity squared, is equal to 4r squared. Okay, let me go ahead and just write this over here. Okay, so this is where we're at right now. Right, so we're almost done at this point. The only thing left to do is just remember that r squared is equal to x squared plus y squared. So we can make a substitution for this right here. And I'm just going to leave this left-hand side in factored form. I'm not going to bother trying to expand that. And then on the right-hand side for r squared, I'm just going to substitute in x squared plus y squared. Okay, so that is how I'm going to leave my final answer. So like I said on the last one, we're not really going to try and simplify these equations. We'll come back around to equations like this in the next unit, like I said, when we start learning about our conic functions. But for now, we're just going to leave them kind of ugly looking. Okay, they're not pretty equations, but we got the job done. We converted it from our polar coordinates and r's and thetas to our rectangular coordinates and x's and y's. So our job is done. We have our answer. Okay. All right, so the last thing then is going the other direction. So this time we're going to be looking at rectangular equations, so equations that are in x and y, and converting them to polar equations. All right, so again, we have the same tools at our disposal. X is equal to r cosine of theta, y is equal to r sine of theta, x squared plus y squared equals r squared, and tangent of theta is equal to y over x. So these are our identities that we can use to potentially solve these problems and convert between rectangular to polar. All right, so on this one, if we're looking at our equation, x squared is equal to 4y, okay? Our first two identities over here give us a way to switch from x and y into r's and thetas. So we know that x is equal to r cosine of theta. So for my x over here, I'm just going to substitute in r cosine of theta. And we also know that y is equal to r sine of theta. So on the right-hand side, I'm going to substitute in r sine of theta for my y. Okay. All right, so now we just need to simplify a little bit, okay? This time around, when we're switching from rectangular to polar, usually these equations will simplify pretty nicely. So we're actually going to do a little bit more work on these in order to simplify these functions, okay? All right, so if we distribute in our square, we're going to get r squared cosine squared of theta, and then distribute in the 4 over here, so 4r sine of theta. Okay. All right, now one thing you'll notice is that we have an r on both sides of this equation. So you can actually go ahead and divide one of those r's out. All right, now if dividing by the r completely eliminated it from the equation, you wouldn't want to do that, okay? It's simply because we still have an r left on the left-hand side when we do that, that it's okay to divide it out. So we would have r cosine squared of theta is equal to 4 sine of theta, okay? Now typically with these, when we're going to polar form, the goal is going to be to solve for r, okay? So we want to try and solve for r. So that would mean we want to divide by cosine squared. Okay. So that would give us r is equal to 4 sine of theta over cosine squared of theta. Okay, now we could leave it there, or we could go even a little bit further and think about some of our basic trig identities. So I'm going to split this up a little bit. I'm going to think of this as 4 times sine over cosine times 1 over cosine. And then if we think about our quotient and our reciprocal trig identities, sine over cosine, remember, is tangent, and 1 over cosine, remember, is secant. All right, so we've finally been able to simplify this down to 4, or r, excuse me, r is equal to 4 tangent secant. So that is going to be our final answer, okay? So like I said, when we're switching from rectangular to polar form, okay, once we substitute in all of our r's and thetas for our x's and y's, try and simplify the equation down as much as you can, which typically is going to mean you're going to want to solve the equation for r. Okay. All right, guys, so that is it for our polar equations. So you should be good to start working on the homework. And the next topic we're going to look at is taking these polar equations and graphing them.